So next, now today we are going to discuss about the Siemens. Okay, so Siemens is one brand. Okay, it's a Germany-based company. So here it's around 175 years plus year old company. So like our automation has started in around 1960s. So it's not that too long, right? So before this, Siemens was into other sectors also, like IT, healthcare, okay, ship, uh, manufacturing, motors, etc., and many sectors. Okay, so Siemens is not only into one sector. So Siemens is after the introduction of automation. Okay, Siemens has entered into the automation part. So they are having different PLC ranges and their own PLCs. Okay, we can say in this Siemens is having different series. So one is S5 series, which was DOS based. Okay, so this uh, series is already stopped. Manufacturing is already stopped because before Windows system, okay, there was DOS system, right? Desktop operating system. But nowadays nobody are using this operating system, right? So we are using Windows based applications like Windows 98, NT, 2000, XP, 7, like this. We are having different upgraded versions nowadays. So Siemens has launched S7 series, okay, which are Windows based like XP, 7, 10, 8, like that. Okay. In this, we are having different PLC ranges. One is a logo, which is a small PLC, a very small PLC for small applications like mostly used in building automation, home automation purpose. Okay, where you need some less number of IOs for small basic applications. Then we are having S7-200 series, which is having different CPU ranges here, CPU 212, 213, 214, like that, up to 229. But this CPU is also stopped. Okay, means manufacturing of the CPU is also stopped because Siemens has launched a new series in that new version, that is 1200. You can see before 200 they added one, so that is 1200. Okay, so it is having features of 200 plus some more features, but engineers who are working on 200 system with the older version of software, uh, they cannot catch up with the new software because Siemens has launched a new software with 200 series also, okay, called TIA portal. So it takes some time for them to learn a new software, right? So till then, Siemens has allowed has launched a new series in 200 series itself as a S7-200 Smart. Okay, so this CPU is still running in this. So in 1200 also we are having different ranges, 1211C, 1212C, 1214C, like that. It is three controllers, logo, 200 and 1200 are known as micro PLCs. Okay, for small applications you can use. Okay, then we are having S7-300 series, which is a medium end controller. In this also we are having different types of CPUs like 312, 313, 314C, 2DP, 2PN by DP, like that, up to CPU 319. Then we're having upgraded version of this 300, that is 1500 series. In this also different CPU types are there. Okay, so Siemens has launched a new CPU series 1500. Okay, which are the upgraded versions of these older versions. Okay, now these two series are known as mid-end, means medium controllers, which can handle more than 1000, 2000, or up to 10,000 IOs also, input and outputs. Okay, if you need more number of handling capacity, for that we go for the S7-400 series. In this there are two types, one is standard and redundant. Okay, standard means here we are having CPUs with only 412, 413, 414, like that. It's like 300 series only, but more input output handling capacity in 400 series. Okay, in redundant, it's like a standby and means it's like a standby system, means master and standby. So here both the systems will be identical, both are having identical systems. Okay, both CPUs will be same. So one CPU will be acting as a master, another one like a standby, means if master is failed, standby will take over. Okay, so these are called high-end system. Okay, high-end controllers. Okay, so these are the different PLC ranges available in Siemens. So next we discuss about the 300 series CPU types. So first one, only CPU module, which will be having such overview, which is having some LEDs on the CPU, some run stop switch here, and memory slot. Okay, so the CPU's numbers will be there, like CPU 312, 313, 314, only a number. There's nothing else written after the number. Okay, and it is having one communication port called MPI. Okay, and MMC card slot. So this is a micro memory card slot is there on the CPU, which is a additional memory card on which we can download our programs. Okay, next CPU type is compact. Okay, compact CPU module. So these CPUs are mentioned with the symbol C suffix. Okay, C will be there. C stands for compact. So this CPU, similarly to this CPU is having some integrated IUs. Okay, integrated inputs and outputs, just like a compact. If I compare with our desktop CPU, PC and laptop, so desktop PC is having separate monitor, keyboard, CPU unit, right? So in laptop all are integrated, right? Monitor, keyboard, mouse pad, all these are integrated. So there's a compact system. So here also we are having a compact CPU. With this CPU some IOs are inbuilt. Okay, and this CPU is also having expandable input output option. Okay, so this is about the integrated or compact CPU. Next CPU type is, you can see it is showing 2DP, 313 2DP, 314 2DP, like that. So on this we are having two communication ports. One is MPA, another one is DP. So on DP we can connect some additional modules, like we call it as remote IOs or VFD, etc. Okay, at long distance communication. Okay, for long distance communication we are using DP ports. DP stands for decentralized peripheral. Okay, for connecting remote IOs. Okay, so remote IOs means suppose our PLC is connected in one control room, and your machine, okay, your machines are connected around say 1 kilometer away. Okay, in there we are having some 10 machines in that plant. So each machine is say having, for example, 200 inputs and outputs. So how many 200 inputs outputs means 10 plants machines are there, means 2000 inputs and outputs. So each input and output will have minimum 2 wires plus and minus for communication, right? So 2 wires means 4000 wires will be there. So can I take all these 4000 wires from that 1 kilometer to the control room, that PLC where your PLC is connected? No, right? Not possible. There are bunch of wires that you have to take from underground. Okay, so underground there is a risky, right? So there will be rats or something, they might cut off the wire. If that wire is broken, you need to again replace the wire, which might take that lengthy wire and some time, right? So to avoid this, we are using a single cable communication option that is called Profibus. So from DP port, you can use this one single cable, and you can connect input output modules at that distance, at that 1 kilometer, 2 kilometer distance nearby the machine itself. So there only you can do the input output wiring. So that's the advantage of using Profibus. Okay. Next CPU type, you can see 2PN. Okay, PN means Profinet, which is having a 800 port. So these CPUs are having one MPI and Profinet port. So this MPI port option, we are having like MPI by PN option, means DP option, means this single port we can configure as MPI or DP also, means if you want to use it as MPI or DP. MPI is generally used for like PC or PLC communication only, okay, whereas this DP is used for remote IO communication or VFD, remote IO communication purpose, okay. And here PN port, it is a Ethernet port. This Ethernet port can also be used for remote IO or as well as with PC PLC communication also, okay. These are the different CPU types are available in 300 series. Next, you can see the overview of the CPU. Here we are having different LEDs on the CPU. They are called SF, DF, DC 5 volt, force, run, stop. So SF means hardware or software fault. Means this LED will be on if there is any programming fault or hardware related faults. Means just now we have discussed about the Profibus. Okay, if there is a disconnection, means this wire is disconnected or cut off. So what happens? This is a hardware related, right? So if that is disconnected, then this SF LED will be on. And this bus fault, which is a bus system. Profibus is one bus system. Bus means data traveling purpose, means transferring data through that cable. So that's why we call it as a bus system. So that's that will get disconnected. So it's called a bus fault. Then next, DC 5 volt. Okay, so here we are providing 24 DC for your CPU, but your CPU requires only 5 volt DC. Whether it is converting it to 5 volt DC or not, for that purpose we are having one LED. Force LED, forcing purpose, forcing inputs and outputs, means if your hardware switch is not working or sensor is not working, but we need to operate that input. Okay, for that purpose we are using a software itself. In that software we are having forcing option. So through that forcing we can make that input on or off. Okay, so whichever the input is under force through the software, so this LED will be an indicator for the force indication. Next, run or stop LEDs are there for the status of your CPU, whether it is in run mode or in stop mode. Similarly, we are having many CPUs which are having two PN by DP, so two bus fault indicators, one for DP and one for PN. Similarly, for the another CPU type like 3 PN by DP, that means it is having 3 bus system options. Okay, so each network will have one bus fault indicator. Okay, now next is about the CPU memory. In your Siemens, we are having a CPU memory, right, which is divided into 2 parts. So we mentioned this in 3 different ways. One is system data memory, which is consisting of PII, that is your process image input. Okay, process image output, bit memory, timer, and counter. So this process image inputs like image input means this for digital. For digital, your image will be 0 or 1 only, right? So for that, storing that in digital status, we are having a memory in CPU. Okay, so we call it as PII. Similarly, for storing digital output status, but this PII and PIQ are for physical input output status, means the hardware status. Okay, hardware input and output status. But if I want to store some temporary values, temporary status of the data and some temporary memory, okay, we should be there in your CPU, not in PC, in your PLC CPU. So there we are having a bit memory as an option, which is also known as temporary memory, where I can store some temporary status of the input output or some condition, okay, or some analog value also I can save. Okay, apart from that, we are having timer and counter memory in CPU. Okay, that is your system data memory. So this timer and counter range is also depending on the CPU types. As we have seen the different CPU ranges, each CPU will be having different capacity of handling inputs, outputs, and bit memory and timer counter. Okay, different memory sizes there. Next, this memory is of two types, means having RAM and ROM. RAM means uh, volatile memory, ROM means non-volatile. Okay, means volatile means if there is any power failure, whatever the data is stored in RAM memory will be lost, whereas in ROM it will not lose any data. Okay, when the power is back, it will display the last values. Okay, there is a RAM and ROM memory which is there in system data memory. Next, load memory. Load memory means user program memory, also known as external memory card. Okay, user program memory is actually a external memory card, so that we call it as a MMC. MMC stands for micro memory card or multimedia card in S7-300 CPU. From 64 KB to maximum 8 MB is the size. Okay, it is external memory card size. You can increase. Okay, it is expandable. So minimum is 64 KB and maximum is 8 MB. Similarly, for S7-400 CPU, we are having memory card MC. Okay, so the minimum size is 128 KB to maximum 64 MB. Okay, now in this memory card, that is a load memory or also known as user program memory, here we are loading our hardware configuration. Okay, so this card is generally a EEPROM card, a flash memory card. EEPROM memory card means even if there is a power failure, your data will not be lost in the memory card. Okay, so here what we are downloading is hardware configuration, means our hardware details. So as we have discussed about the different CPU types, right? So what CPU type we are using, okay, what input module type we are using, how many input outputs we are using, okay, all these hardware details you need to download to the program memory. Okay, then apart from this, we are also downloading program blocks, that is your organization blocks, OBs, function blocks. These are known as subroutine blocks. Other blocks are like system function and system function blocks. These are predefined blocks. Okay, so for some process you no need to program. Okay, so directly you can use these blocks. Ready to use blocks are there, system function and system function blocks, that also you can use and do the means small settings, means addressing you have to do and download. Okay, other blocks like data blocks, memory. Okay, these are additional memory blocks in which you can use. It's also a temporary memory, as we can say. So here bit memory is a generally is a RAM memory, but some memory you can assign as a ROM, that you have to do the setting in the CPU properties. Okay, whereas data block memory is by default a retentive memory. Retentive means which stores the last values. Okay, last data. Even there is a power failure, data will not be lost in the data block memory. Okay, so this is about the load memory. Next, work memory. Work memory means what it is doing is execution of program blocks, that is sequential execution of program blocks. It is executing your program blocks in sequential order, means step by step. Okay, so this is about the CPU memory. Okay, CPUs and the CPU memories. Okay, next, so this work memory is a RAM memory generally. Okay, means if there is a power failure, whatever the logic blocks are executing here will be lost. Okay, again when the power is back, okay, then again it starts from the beginning. Okay, it stores the data and takes the data from the memory card and execute it one by one. Okay, now this is about the CPU memory. Next, we discuss about the addressing format. So what is addressing? Addressing means as we are using large number of inputs and outputs, okay, to identify those particular inputs and outputs we need some identifier or some address. Okay, so here we are using a addressing format called identifier identifier means symbol, okay, for your inputs and outputs. Then byte number dot bit number order. So we're having these files PII, PIQ, bit memory, timer and counter. These are the files which are available in your CPU, right? So to identify them, we are using symbols. So these symbols are I for inputs, Q for outputs, M for bit memory, T for timers, and C for counters. Okay, so these are the identifiers for these files, CPU files. Okay, now next, here you can see 1 bit is equal to 0 or 1. 1 bit means 0 or 1 means on or off. If I take these bits in a group like 4 bits, that is known as 1 nibble. Okay, same way 8 bits is equal to 1 byte. Group of 8 bits is 1 byte. Similarly 16 bits, that is 2 bytes, or also known as 1 word. 32 bits, 4 bytes, that is 2 words, or we call it as a double word. So we need to remember these things, okay, or always calculate in this order. Like for example, if I say 1 word, that means 2 bytes, 16 bits. If I say double word, always like 2 words, 4 bytes, 32 bits, okay, or 32 bits if I say 4 bytes, 2 words, that is 1 double word, okay, like that you should remember these things. Okay, so we are going to see the addressing concept with the bit memory first. Okay, so this means the addressing concept is similar for your inputs and outputs. Okay, so better we see with the bit memory. So it depends on the size of the memory is available on the CPU. Okay, so some CPUs are having like 1024 bits or 2048 bits or 4096 bits, like that, up to 65536 or more than this also. So suppose our CPU is having 2048 bits. Okay, 2048 bits. Okay, but your Siemens is using byte number order, means byte level addressing. That means we need to convert this number of bits, 2048 bits, to bytes. So how you can convert? By dividing this bits by 8. So 8 bits means 1 byte. So is equal to how many bytes? We get is 256 bytes. That means byte number 0 to byte number 255. So here 0 is also included here as a byte number. So byte 0 to 255. This is the order for reading the address here. Okay, so this is about the addressing format we are using. Okay, so let's see how to assign the address, how to define the address here for bit memory. Now bit memory addressing symbol is M. Symbol is M. Bytes are starting from 0 to 255. So we are having different level of addressing here: bit level address, byte level address, word level, and double word level. So for bit level, here you can see M is the identifier, then 0 is the byte number dot bit number. Okay, so in this bit memory address, we are storing one value, right? 0 or 1, only 0 or 1, any one status I can store. Okay, so similarly for the next bit, what's the address here? M0.1. okay, then it is going up to M0.7, means M0.0 to M0.7. so there are 8 bits in 1 byte. This is a byte number 0, right? So in this byte number 0, we are having 8 bits, 0 to 7. Okay, so next byte will be, after finishing this byte, next byte will take over, means M1.0 to M1.7. Similarly, we are having other byte numbers 2.0 to 2.7, 3.0 to 3.7, like this. It will go up to 255.0 to 255.7, the last byte number. Okay, now next is byte level address. 1 byte means 8 bits, right? So for byte, we are having a B as a symbol. So M B 1 byte, byte number 0. okay, for 1 byte. Okay, so we are not giving any 0.0, 0.1 here. 0.0, 0.1 only we are giving for digital addressing or a bit addressing. Okay, here you can see. Okay, but here we are not giving any bit address, we are giving a byte address. Byte means a group of 8 bits. So MB0, next will be MB1, MB2, MB3, like that up to MB255. Now in 1 byte you can store a value between -128 to +127. If we consider binary to decimal conversion, means binary means zeros and ones, right? So 8 bits, 8 bits, for 8 bits it is 2 power 7, 2 power 0 to 2 power 7. So for that you will get the value between -128 to +127 only. But this is not enough, right? So our values will be more than 128, 127, right? 120, more than 127, sorry. So 128, 200 something. So that I cannot store in 1 byte in this address. So what I need to do is we need to increase the memory size. How I can increase? By adding these 2 bytes. Say I am adding MB0 and MB1. I am adding MB0 and MB1. Okay, so this becomes 1 word. 2 bytes means 1 word. That is, it is having total 16 bits. From M0.0 to M1.7, total 16 bits. Okay, so addressing is like okay, here you can see addressing is like MW0. M memory, bit memory, W means word, 0. 0 I am giving for the first byte number here. In this word there are 2 bytes are added, MB0 and MB1. Okay, in the next I am adding MB2 and MB3. So here address will be MW2, not 1. If I give 1, it will consider these 2 byte numbers MB1 and MB2, right? So here which byte numbers we are adding? So the first byte number only we have to add here. So in MW0, 0 and 1, MW2, 2 and 3. Next address will be like MW4, MW6, all in an even order. Okay, so these are the byte numbers. Okay, these are the byte numbers. So MW252 and MW254, right? So these are the word level address. Now in 1 word I can store this much of value, that is -32768 sorry, it should be 68 not 86 to +32767. Okay, so here also if I see the value is only up to 32,000, right? If we have to store more value, 40,000, 50,000, 1 lakh, so this memory is also not enough. So we develop the word. Okay, so it becomes a double word. In this double word, the order is MD0. Okay, MD0, which is having 2 words and these 4 bytes and total 32 bits. Okay, similarly for the next double word MD4, I'm adding MW4 and MW6 here. Like that, it is having MB4 to MB7, right? So like that, we are having 4 bytes and 32 bits. Next will be MD8. Okay, like this, it goes up to the last one, MD252. MD252 means it is having these 2 words and these 4 bytes, and these are 32 bits here. Okay, so this is about the addressing format for your bit addressing. Okay,